Associativity for whole numbers. Recall the associativity of 4 operations for whole numbers through this table. Addition. Associative means if we have 3 numbers, 3 whole numbers, 3, 4 and 5. If we add these numbers by changing their groups, means first we add 3 and 4, then we add 5 in that sum. Or if we add 4 and 5 plus first and then we add 3 to their sum. Here this is 3 plus 4 is 7, 7 plus 5 is 12, and here 4 plus 5 is 9, but the answer is 3 plus 9 is 12. So if we change grouping of the whole numbers, then also we get the same answer. Therefore addition is associative under whole numbers. But this is not true for subtraction. If we want to subtract these numbers by changing their grouping, this is -1 and -5, so answer is -6, and here this is 3 minus -1, 4 minus 5 is -1, minus of minus becomes plus, and these answers are not equal. Therefore subtraction is not associative under whole numbers. Multiplication. Let us consider same whole numbers and find out their product by changing their groups. Here this is 12 into 5, which is equal to 60, and this is 3 into 20, which is also equal to 60. Therefore multiplication is associative for whole numbers. Division is not associative. If we divide 12 by 3 and let us divide that answer by 2. Now let us change the grouping, and 12 divided by 3 divided by 2. This is 4 divided by 2, it's 2, and here 12 divided by 3 divided by 2 is 1.5, and answer is not 2, it will be something different. If we want to find out, we can find it as yes, and the answer is 8, which are not equal. Therefore division is not associative. Same is for integers. If we change grouping for integers, -2 plus 3 plus -4, here the answer is, this answer is -1, -2 plus -1, so answer is -3, and let us find out this. -2 plus 3 -4, this is 1 minus 4, which is equal to -3. So addition is associative. Similar to above table, subtraction of integers is not associative. Multiplication is associative and division is not associative. So for whole numbers and integer, the results are same. Addition and multiplication are associative, and subtraction and division are not associative. Same can be proved for rational numbers. Addition is associative for rational numbers. Subtraction is not associative for rational numbers. Multiplication is associative for rational numbers, and division is not associative for rational numbers. Addition is associative for rational numbers, subtraction is not associative. Multiplication is associative and division is not associative. For integer, the results are same. Addition and multiplication are associative, and subtraction and division are not associative. Subtraction, yes, multiplication is associative, division is not. For natural numbers, addition is associative and multiplication is associative, and subtraction and division are not associative. Here we solve this example. 3 upon 7 plus minus 6 upon 11 plus minus 8 upon 21 plus 5 upon 22. We cannot add these numbers unless their denominators are equal. So we can make the denominators equal. For that we have to find out common multiple of all these numbers. Common multiple of 7 and 21 is 21, and 11 and 22 is 22. So let us find out common multiple of 21 and 22, that is LCM of 21 and 22. We can find out that LCM by this method. Let us divide these numbers by 2. We cannot divide 21 by 2, so we keep that unchanged and we divide this by 2. We get 11. Now these two numbers are not divisible by 2, so let us check for 3. This is not divisible, so we will write as it is. Now 7, 1, 11, now 11. So we continue until we get 1 for all the numbers. Now multiplication of these numbers is our LCM or common multiple. This is 6 into 7 into 11, that is 42 into 11. 22 carry 2, 44 plus 2 is 46. So common multiple of all these numbers 7, 11, 21, 22 is 462. So before we add these numbers, let us make their denominators equal. For this we have to multiply this number by 66. 11. We have to multiply this number by 42. This number by 22 and this by 21. Both numerator and denominator. Now we have denominator same, and that same denominator is 462. 66 into 3 is 198. Now this number is negative, so product is negative. 42 into 6 is 252 minus 176 plus 105. Now these are positive and these are negative. Let us add them separately. 198 plus 105. This is 303. And let us add these numbers. They are 428. So next step is (303) minus 428 divided by 462. Now this bigger number is negative, so answer is negative. 8 minus 3 is 5 and is 12. 42 minus 30. So our answer is minus 125 divided by 462. This is for multiplication. Multiplication of rational numbers. Minus 4 by 5 into 3 by 7 into 15 by 16 into 14 upon 9. Here we have multiplication of all these fractions. So the numbers in numerator can divide the numbers in denominator and vice versa. So 5 can divide this 15. 5 3s are 15. This 7 can divide minus 14 and we get here minus 2. This 3 can divide 9 to give us 3. This 4 minus 4 can divide 16. One of the number is negative, so answer is negative. Now let us cancel these 3 here. These are now what we left with, minus 2 upon minus 4. Division of two negative numbers is positive, and this is 1 by 2. So final answer is half. The role of 0. Addition of 0 with whole number. Consider any whole number, add it with 0, you will get the same whole number. Addition of 0 with integer. Minus 5 plus 0 is minus 5. Addition of 0 with rational number will give us the same rational number. So here we find that when we add 0 to whole number, the sum is whole number, and this is true for integers and rational numbers also. So 0 is called as identity for addition of rational number. It is also additive identity, that is also called as additive identity. 0 is additive identity for rational numbers, integers and whole numbers also. The role of 1. If we multiply any whole number by 1, we get the same answer. If we multiply any rational number by 1, we get the same rational number. So 1 is called as multiplicative identity for rational numbers, and it is also true for integers and whole numbers. So 0 is called as additive identity and 1 is called as multiplicative identity of a